Alright guys, so we're going to move forward into chapter 10 some more. This time we're going to talk about metric units of measurement. Last week we were talking about customary units. So metric units, just a little background, is the units that the rest of the world uses when they talk about measuring things, except for us in the United States. So some of the stuff is familiar because it follows patterns that we talked about a long time ago in the beginning of the year, but it is, personally, in my opinion, a lot easier to remember than the customary units. So we're going to start talking about a little bit of something that you know already and kind of meld that into metric units. I do want to say that today's video is just an intro. It's kind of to give you a little taste of what metric is and how it works. There are no practice problems in this video. Practice problems are going to start when we talk about specific types of measurement in the metric units. So, do you remember this? This chart is at the top of my classroom, in front of the room, on top of the Promethean board, if you remember. It is the exact same thing. I use the same colors and everything, so it is identical to try to jog your memory. The reason why I have this here is because it is kind of helpful for us to understand metric units with this place value chart. Because they follow similar rules, so we're going to talk about the rules that this place value chart follows and how it is similar to when we're using metric units. So every time we go a place value to the left, means our place value is getting bigger. We are getting 10 times bigger. So we are going times 10 each time we jump a spot over. If you remember in my room at school, I have the times 10 arrows going every spot over to the left. Every time we move a place value to the right, meaning our place value is getting smaller, we are going to be getting 10 times smaller. Sorry, my typo here, guys. So we are dividing by 10 every time we go to the right. And then at school, I have those arrows that say divided by 10 underneath the place value chart to help us remember which operation we do depending on which way we go. So that kind of comes in handy for us because our metric units kind of follow a similar pattern. We'll talk about that in a little bit. Realistically, what we're doing here with our place value chart is we're thinking about it this way. That there are 10 ones in one 10. That means I need 10 little tiny cubes to make one French fry. I need 10 of one place value. It doesn't matter which one, because the pattern continues through the entire place value chart. So for example, looking at the chart in front of us right now, if I had 10 hundred thousands, I don't know what those cubes would look like, but if I had 10 hundred thousands, I would have 1 million. I just move one spot over. Once I have 10 of something, I can move to the left. Okay? Something that we talked about earlier in the year is, it's kind of relevant to what we're doing now, so this is why we're bringing it up again. So this is our chart table thing that we're going to use for metric units. This you're going to see in the rest of this video. It'll probably get incorporated into tomorrow's video and the day after and so forth, just to keep it consistent so that you're seeing it and having it as a reference to use in case you need it. So again, it follows similar rules to the place value chart where the times 10 divided by 10 thing is still applying. It just looks a little different. So if our base is 1, right, and the rule is that every time we go to the left, we're getting 10 times bigger. Our deca spot would have a 10. It would be 10 times bigger than our base. Our hecto spot would have 100 because it's 100 times bigger than the base. And the kilo spot would have 1,000 because it's 1,000 times bigger than the base. Every time we move to the left, we are moving times 10 each place. Each box is times 10 more. That's going to come in handy when we have to start converting in the next coming lessons. Now, keeping our base at 1, if we're going the opposite direction, going to the right, instead of timesing by 10 or multiplying by 10, we should be dividing by 10, right? So we're getting smaller 10 times every time. So decigrams or deci whatevers are 10 times smaller than the base. So it would be divided by 10 to get to the deci spot, which is why our 1 became a 1/10. Then the centi spot would be 100 times smaller, which means it would be divided by 100, which would get us to 1/100th. And then finally, our milli spot is 1,000 times smaller, so we would take 1 and divide it by 1,000 to get to 1,000th. So every time here we're moving to the right, we divide by 10 each spot over. If you look, you can kind of see a little bit of a pattern. If you think about where the decimal is in every single one of the numbers that is inside of the table right now, 1, 10, 100, 1,000, 1/10th, 100th, 1,000th, you might notice that there's a little bit of a pattern happening here with the decimal, and you might also remember back in, I want to say it was chapter 1, maybe? No, chapter 5 maybe? When we were talking about decimals and powers of 10, follows a very similar pattern to that also. So hopefully once you see a couple of them, it will jog your memory and you'll be like, oh, wait, I know how to do this. I remember doing this with something else. Essentially what we are doing here, this is my big giveaway to you. Essentially what we are doing here is we're moving the decimal either to the left or to the right, depending on which measurement we need to end up in. So in the future, say I'm starting with 1 meter, and I need to end up in millimeters. I know that looking at my chart here, that the base is in the middle and the millimeters are all the way to the right. I'm going to move my decimal all the way to the left so that my spot can move over. We're going to do practice one like this, I promise. It'll make more sense when you see it. And then the next 3 days are going to be lots and lots of practice with it anyway. So if right now it makes no sense, that's okay. Don't freak out. Hopefully, after the next thing I'm going to show you, it will make a lot more sense. So check out the video that I'm going to show you. I have it played in here for you. If you want to go look at it separately on your own, there's the link. You can type that into your browser on your own. But I do have the video in this video. It's coming up next, so just hang tight. Don't go anywhere. Watch the video, okay? I promise. It's actually super catchy. Every time I've shown this video, my classes get super, super into it, and like for a week straight, it's all I hear. So if the song gets stuck in your head, I'm super, super sorry. And parents, I apologize in advance for having to hear the song probably 100 times this week.
You know, I figured out how to memorize the metric system. It's all based on powers of 10. So you just need to memorize a couple Latin prefixes and then you can measure anything. Just remember King Henry. Oh, you don't know about King Henry? Listen up. King Henry died drinking chocolate milk. 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 It goes kilo, hecto, deca, deci, centi, milli, weight. Kilo, hecto, deca, deci, centi, milli. King Henry ordered cocoa by the kilogram. That's 1,000 grams, we could barely fit it in the van. The driver drove over a hectometer, 100 meters with no AC in the two-seater. I was feeling like a joker in a deck of cards, milking cows by the decaliter in the barn. 10 liters at a time when I saw the van driver and gave her a piece of my mind. I whispered at a decibel, 1/10 of a bell, saying that King Henry wasn't checking his health. She made her finger small like a centimeter, 100th of a meter, and said, please believe her. If he gets this much bigger, he might explode. I agreed, even the milligram of cocoa, 1,000th of a gram might change the throne, cause hot chocolate can make a king turn cold. King Henry died drinking chocolate milk. 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 It goes kilo, hecto, deca, deci, centi, milli, weight. Kilo, hecto, deca, deci, centi, milli. Kilo, hecto, deca, deci, centi, milli, weight. Kilo, hecto, deca, deci, centi, milli.
Okay, so I hope you liked the video. I hope the video was super catchy. That song is going to help you remember all of the different orders, the order of the measurements: kilo, hecto, deca, base, centi, deci, centi, milli, weight, right? So it's going to help us just remembering which one comes first, which one comes next, and like what order they go in when we're trying to do our units conversion. But again, we are always going to have that table there to help you. So even if you don't remember the song and it wasn't catchy or it was just super annoying to you, the chart's always going to be there to help you anyway. So don't worry. So metric system is a little different than, well, a little similar, but also a little different than the customary system. So the metric system also has length, weight, and capacity like the customary system did. Time, like I said to you in the last video, is like completely separate from itself. It's not really customary or metric because it's everywhere. So metric does have those same 3 categories, those 3 different measurement types. We just use different units when we measure them, and they, again, follow a little bit of a different rule. So length, again, is the distance measured between 2 points, and for metric units, we're going to use meters. The weight of an object is how heavy the object is because of its mass and gravity, and for metric system, we're going to use grams as our unit. And then the capacity of a container is the amount the container can hold, kind of like its volume, right? And for this, we're going to use liters. I promise our little friends are coming back, our little animated friends, they are going to come back. But we will talk about length, weight, and capacity throughout the week. For now, let's talk about this new chart and how do we use it, right? How is it going to be helpful to us? What exactly are we doing with metric units? So here's that chart again. Kilo, hecto, deca, base, deci, centi, milli, weight. So the units of measurement, as you can probably tell from the video and from what I just told you, are that we're going to be talking about are meters, grams, and liters. And in parentheses next to each of those are their abbreviations. So in case I start using those instead, or when you do them in your work, it might make it easier. Those are all of our base units. So meters, grams, and liters they are our base units. So if the example that you have is 10 meters equals blank kilometers, you know that the 10 is going to go in your base spot, right? That's your base. So if meters, grams, and liters are our bases, they're going to be in that middle box. Now, let's pretend that we have 1 gram of sugar. I put my 1 in my base box. And now I want to convert my 1 gram of sugar into decigrams. So like on your practice problems page, it says 1 gram equals blank decigrams, right? We have to figure out how many grams are equal to how many 1 grams is equal to however many decigrams, right? So here's how we do it. We take our 1 gram and we rewrite it as a decimal. Now, 1 is a whole number, so the decimal is already there. It's just invisible, and it is at the end of the number, right? So 1 becomes 1.0, 1 decimal 0, right? 1 gram equals 1.0 grams. First, easy step. Write it as a decimal. Second step, move the decimal to the right 1 time because decigram, the place for decigrams, the orange box, is 1 spot to the right of the base place. Okay, so let me break that down for you just one more time. We start in the base because that's the unit we started with, a base unit, grams. No kilo, hecto, deca, deci, centi, milli, just grams. So we start there. That's why it's pink. Then we need to end up in decigrams, which means my decimal needs to be on the end of my decigram spot. So because it's 1 spot to the right, I move my decimal over 1 spot to the right. So 1 gram of sugar is, scoop my decimal over, equal to 10 decigrams of sugar. Okay, I know it sounds super complicated. I promise it's really not as complicated as we think it is. Once you see me break down a couple of the other ones in the upcoming videos for tomorrow, Wednesday, and Thursday, it will make a lot more sense. Once you walk through a couple of them with me, it will make sense. Right now, I just wanted to kind of give you a small dip your toes in the water type situation so that you weren't completely overwhelmed, because it is something that is we're not used to, because we don't use this in our everyday lives. So, wanted to break it down, slow it down for you so that we were all going to be on the same page. Okay? So, in conclusion here, we ended up with 10 decigrams being equal to 1 gram just by moving the decimal over to the right. Now, like I said, there are no practice problems in this video today. Tomorrow there will be, Wednesday there will be, Thursday there will be. On the next couple of slides, I have some common questions that I kind of answered, like how do I submit my work? How do I ask a question if I'm confused on something? The directions are coming after I'm done talking. So I hope the video made sense. I hope you check out how to submit your stuff. If you are on Google Classroom and you want to go back and do some of the assignments on Google Classroom in the Google form, be my guest. If you already gave them to me on Remind, then that's fine. I have them. Don't worry about it. But if you want to be my guest, go ahead. It's a little easier on the Google form, to be totally honest, because of the way it's formatted. And if it marks it wrong, but shows you the right answers and what you typed is technically correct, I can go back and change it, so don't freak out. Okay? I feel like I did a lot of talking today and a lot of rambling, but I did want to get a lot of information out to you guys. So keep watching for more important information on how to do certain things with your assignments today. All right, cool. Thanks, guys. Bye.